Okay, so today's lesson is about arithmetic sequences. We're going to learn to identify what an arithmetic sequence looks like. We're going to talk about writing recursive formulas. The word recursive means backwards, so we'll talk about that, and also explicit formulas. Some vocabulary before we start. A sequence is just an ordered list of numbers that form a pattern. So when we were writing function rules, when we had our list of, we made our table, we had our x values and our y values, each set of numbers made a sequence. So the y values made a sequence. And the term of a sequence, each number in the sequence is a term. So if we have a list of 5 numbers, the first number is the first term, the second number is the second term, and so on. So first what we're going to look at is just describing a pattern in the sequence and then deciding what the next 2 terms of the sequence are. So we're not actually writing an equation yet or a formula for the sequence. We are just describing the pattern, figuring out the next 2 terms. So I want to give you guys a couple minutes to look at these patterns, decide what the pattern is, describe it, and then figure out the next 2 terms. Okay, letter A. Zoe, what pattern is going on there? How would you just describe that? Adding 6. Good. So our pattern is adding 6. What would the next 2 terms of that sequence be?
29.
Good. 29 and 35. Okay, how about letter B over here? Emma Musser, how would you describe the pattern?
Just did it, but I don't know.
Would it be easier to tell me the next 2 terms first?
Yes.
Okay.
I'd say 25,
Mm-hmm.
and then 12 and a half.
12 and a half. Good. So what are we doing? How did you know that was 25? What did you do?
Because like 400 split in half is 200, 200 split in half is 100, 100 split in half is
So we're splitting them all in half. So we could say we're dividing by 2 for that pattern. Cat, letter C. Do you know what's going on there?
What I did was like, I did I made it -2 and then I squared it by 2. And then I hit that with everything.
Okay, made it -2 and squared it by 2. So what was your next term here?
I'm not really sure. I was like thinking off with my feet.
Okay, so you're not quite. Any volunteers on this one? Besides Gretchen?
I would say times
Times -2. Good. Times -2. And then what would my next 2 terms be? Go ahead, Emma.
32 and negative 60.
Good. 32 and negative 64. Okay, and then the last one, letter D. Cole, what pattern is going on there? Plus 4. So what would the next 2 terms be? Good. Okay, moving on to the next page. This leads into what we're going to talk about here. When we have an arithmetic sequence, the difference between consecutive terms is constant. So in other words, it goes up or down by the same amount. This is like when we were writing formulas for functions. If we had a linear function, the difference was constant. So this kind of goes along with a linear function. If we have a sequence and they are y terms, then it would be a linear function. Common difference is just the difference between terms in an arithmetic sequence. So going back to the page we did before, letter A would be an arithmetic sequence because it's going up by the same amount each time, and the common difference would be 6. Letter D would also be an arithmetic sequence because it's going up by the same amount each time, and the common difference would be 4. Okay, so now in this set, we're going to tell whether the sequence is an arithmetic sequence, and if it is, what is the common difference? Okay, so let's just kind of do these as we go. So we're just looking to see if they go up by the same amount. Colin, what do you think? Is this one an arithmetic sequence?
Yeah.
Yes? Okay, what's the common difference?
Never mind.
It's not. Okay, why not?
As it doesn't go over the same.
Right, goes up by 7, 7, and then 8. So this one is not an arithmetic sequence. Okay, what about B over here? Olivia, is this one an arithmetic sequence?
Yeah.
Yes, what's the common difference? Plus 2, good. So yes, plus 2. Okay, how about letter C, Bailey? Yes, and what's the common difference? Good. Okay, and letter D. Sophia? No, why not?
Because it goes down by 4 and then up by 4 and down.
Yeah, it keeps switching and going back and forth. Okay, good. Now, on to the next part. A sequence is a function whose inputs, or domain, is the natural numbers, and whose outputs, or range, are the terms of the sequence. So the inputs, meaning the natural numbers, is just 1, 2, 3, 4, 5. So if we have a sequence, like the sequence down here, 3, 6, 9, 12, this is the first term, second term, third term, fourth term. So our domain is just 1, 2, 3, 4. Okay, and then the outputs, or the range, are the terms of the sequence. Some things, some notation that we use when we're dealing with sequence. N stands for the term number. A of n stands for the value of the nth term. So instead of x and y, like we had in our table before, we're still doing the same thing. We just have a different notation. We're going to have n and a of n. So given this sequence, 3, 6, 9, 12, we can rewrite it as a table, just like we did when we had ordered pairs. We're going to always start with 1, 2, 3, write as many numbers as we have terms in the sequence, and then the actual terms get written over here as the y values. Okay, I want you guys to make a table for this sequence: -3, -2, -1, and 0. So just quickly make a table just like I did. Let's just make sure you understand how to make the table. Okay, what am I going to put as the headings in my table? Athena, what are you going to put up here?
N and then A of n.
Good. Okay, what numbers am I going to put in the left, Hannah?
1, 2, 3, 4.
Good. And then what numbers will I put on the right, Gabby? Good. Okay, good. You guys get the gist of that. Now, let's talk about recursive formulas. A recursive formula is a different kind of function rule. It's a function rule that relates each term of a sequence to the ones before it. So, A of n stands for the nth term. So it could be any term that we're talking about. A of m minus 1 is talking about the previous term, so the term that came right before the nth term. So if it asks us to write a recursive formula for a sequence, the first thing we do is make that table. So we have n and a of n. N is going to be, I have 4 terms, so I'm going to do 1, 2, 3, 4. A of n is 7, 11, 15, and 19. And then we're going to make an equation just like we did before, but instead of having x and y, we're going to have a of n and a of m minus 1. We're going to talk about what we did to the number before to get the next number. So who can tell me what the pattern is in the a of n column? What's going on there? Colin? It's just plus 4. So we're taking each term and we're adding 4 to it. So to get the next term, to get a of n, to get any next term, we're going to take the previous term, which is a of n minus 1, and we're going to add 4. This is a different type of formula. It's not relating the term number at all. It's just saying, what do we do to the previous term? And they always look like this. No, I do not. I have this poster up that gives you a lot of information from this unit just because there's so much. I have another one that has the rest of it, so I have to find the next one and stick it up. This is the formula we use every time. So a of n equals a of n minus 1, and then plus 4, or plus 8, or minus 2, whatever you end up doing to the previous term. The notation is confusing, but it's actually not that difficult to do. We are not going to do explicit formulas today, so we're going to stop here with recursive formulas. I'm going to give you your assignment. Since it's Friday, you'll have time to work on it. Okay, let's see. We're going to do, let me just double check this.